So we can go ahead and start with 15. Which of the following has a triplet? 3 hydrogen 1.1, a doublet 6 hydrogens 1.2 ppm, and you will have a quartet 2 hydrogen 2.4 ppm. Okay, so let's see. Okay, what are the things that we have over here? We have a triplet 3 hydrogens. So then now you know how we get a triplet 3 hydrogen, meaning you should have 3 hydrogen, and this would be a triplet due to the adjacent hydrogen having 2 hydrogens. So this carbon would be a triplet due to the 2 hydrogens on the, if this is A, due to the 2 hydrogens on B carbon, and this comes around 1.1 ppm. And then you should know that we also should have a signal that is 2 hydrogen quartet. So the 2 hydrogen quartet is due to this, it's going to be this carbon, carbon B. There are 2 hydrogens, and those 2 hydrogens would be split to N plus 1. N is now 3 plus 1, meaning 4 hydrogens. So we should have a piece where it says 2 hydrogen a quartet. Do we have that? A quartet 2 hydrogen. You see that at 2.4. So these two pieces where it says a triplet 3 hydrogen, a quartet 2 hydrogen is this piece that I just drew. Right? It complements each other. 3 hydrogen triplet, 2 hydrogen quartet. And then what else do we have? We have a doublet, 6 hydrogen, a doublet. Meaning we should have a part like this in our molecule. There are 6 hydrogen, they are in the same environment, and on this carbon should have only 1 hydrogen. So that tells us these 6 hydrogens. These 6 hydrogen on this carbon going to be a doublet due to this hydrogen. Doublet N plus 1, N is 1 hydrogen, 1 plus 1, 2. So the 6 hydrogen doublet. Okay, and similarly the 1 hydrogen that we have here is going to split due to the 6 hydrogens on the neighboring carbons. So since excuse me, N going to be 6, N plus 1, 6 plus 1 to a septet. So we should have a 1 hydrogen, a septet. Okay, so that is doublet 6 hydrogen at 1.2 and a septet 2 hydrogen. So these are the pieces we have. So in our molecule we should have these 2 pieces together. Okay, and do we see that in A? No, A is out. And then the B looks like we do have 6 hydrogen a doublet and a 1 hydrogen septet, 2 hydrogen quartet, and 3 hydrogen a triplet. So this look like it, but we'll see. And then C is a symmetrical molecule. There are 6 hydrogens over here, could be a doublet, and these 6 hydrogen also going to be similar to the other one. So we don't have a triplet and a quartet, so that's wrong. Okay. And then D. Do we have a part like 6 hydrogen doublet? No, so D is out. And then the E is also out because it only has a triplet and a quartet. So the correct answer is going to be then B. Okay. And then number 16, the indicated hydrogens HA and HB are number 16. Okay. Now, if you have a stereo center in the molecule, meaning you have an asymmetric atom is a stereo center or a chiral center. More than a stereo center, you can consider it as a chiral center. Chiral center is an unsymmetrical carbon which carrying 4 different groups on that carbon. If you have that, and then if you have 2 hydrogens in the molecule, so we can consider them as a diastereotopic hydrogens. Now HA and HB over here, right, 2 hydrogens. And then look at if you have a asymmetric carbon in your molecule. Do we have any asymmetric carbons? Now if you look at this carbon, this carbon would be more likely a diastereotopic hydrogen. Okay, be quiet. Okay, so here, remember the enantiotopic would be if you don't have a asymmetric center, a chiral center. But in this one, we do see a stereo center, meaning if you replace one of the hydrogens with another molecule, another atom, this would give us two diastereomers. So making it a diastereotopic hydrogens. Okay. So the answer for 16 is B. Okay, number 17. How many signals are in the carbon 13 in the following compound? Now it is carbon 13, not proton NMR. So then how many different signals would you expect for this one? So here you have one carbon. This is going to be different from the rest of the carbons in the molecule. 1, 2, 3. This would be different because this has a ethyl group. So the third one. And then you have a different one here. Fifth one. 1, 2, 3, 4, 5. And these two would be in one place. And these two would be in another carbon environment. So altogether it would be 1, 2, 3, 4, 5, these two, 6, 7. So it's going to be 7. 18. What's the splitting pattern in the proton coupled carbon 13 NMR? Proton coupled means now in the proton NMR we talk about the hydrogen proton NMR spectrum is given due to the splitting due to the neighboring hydrogens, neighboring carbon hydrogens. But on the carbon 13, it's not the neighboring carbon, it's just the hydrogen on the same carbon. For example, if this is carbon spectrum, if it is carbon coupled or proton coupled NMR, meaning this carbon will split due to n plus 1 hydrogens on the same carbon. So there are 1, 2, 3. So this carbon would be a quartet. Okay. And then if the other carbon, this one has only 2 hydrogens like this, and this is something else. So the carbon B would, if you couple it with the proton, it would be a triplet because there are 2 hydrogens. N plus 1, it would be a triplet. Okay. Whereas proton NMR, it's the neighboring carbon's hydrogens. Okay. Now what's the splitting pattern in the carbon 13 NMR? So let's see. A, meaning there are 3 hydrogens there. So A would be a quartet, N plus 1. Okay, A is a quartet. And then what about G? G also has 3 hydrogens, so G also would be a quartet. G would be a quartet. And then what about B? B has 2 hydrogens, so N plus 1, it would be a triplet. B would be a triplet. Okay. And then what about D? So there is a hydrogen. There is a hydrogen. So D are going to be in the same environment. D would be a doublet because it's only one hydrogen there. So D would be a doublet, and also E would be a doublet too. So D and E would be a doublet. So A and G quartet, B triplet, and D, E doublet. What about the C? So C is this one, C and F. Do we have any hydrogens on it? No, since there are no hydrogens on it, it's saturated, meaning it has 4 bonds. It's not saturated, but it has 4 bonds, the maximum number of bonds on carbon. So there are no hydrogens, so then the C and F would be a singlet. Okay, so that will give you the answer as B.